3. I-Atlas has reappeared from behind the sun, and the first images captured after perihelion reveal something that violates every law of stellar thermodynamics we've built our understanding of the cosmos upon. The object is glowing bluer than the sun itself, not reflecting sunlight as comets are supposed to do, but emitting light as if powered by an internal engine hotter than the star it's orbiting. This isn't a subtle measurement error or an instrument calibration issue. 3 independent space observatories, positioned where Earth-based telescopes couldn't see, all documented the same impossible signature. Blue light streaming from an object that should be dark and cold, or at best, faintly red from reflected solar radiation. On October 29, 2025, at precisely 11:15 Universal Time, 3I Atlas reached perihelion, its closest approach to the Sun, plunging to within 203 million kilometers of our star's roiling photosphere. For weeks leading up to this moment, the object disappeared from Earth's view, hidden behind the Sun during what astronomers call solar conjunction. From October 21st through early November, ground telescopes saw nothing. The most critical observation window of this interstellar visitor's journey through our solar system occurred while we were blind, standing on the wrong side of our star to witness what was happening. But 3 spacecraft weren't blind. Stereo A, orbiting slightly ahead of Earth in its path around the Sun, captured continuous data with its coronagraph instruments. SOHO, stationed at the gravitational balance point between Earth and Sun, monitored with LASCO imaging systems. And GOES-19, a meteorological satellite launched just last year with the most advanced coronagraph ever deployed to geostationary orbit, resolved details the others couldn't. These 3 mechanical witnesses documented something that has Harvard astrophysicist Avi Loeb calling for immediate international scientific response. What they saw was the 10th anomaly, the culmination of a pattern so statistically improbable that dismissing it requires more faith than confronting it. Blue light means high temperature. It's not metaphorical. It's not interpretive. It's blackbody radiation physics that every undergraduate astronomy student learns in their first semester. When objects heat up, they emit light at specific wavelengths determined entirely by their temperature. Cooler objects glow red, hotter objects glow blue. Our sun's photosphere burns at 5,800 degrees Kelvin, giving it that familiar yellowish-white appearance. At the distance 3I Atlas reached during perihelion, natural objects exposed to solar radiation should heat to roughly 290 Kelvin, about 20 times cooler than the sun. Objects that cold emit infrared radiation, invisible to the human eye, and if they reflect visible light at all, it skews toward the red end of the spectrum. 3I Atlas is doing the opposite. The coronagraph data shows emission spectrum shifted toward blue wavelengths, indicating surface temperatures potentially exceeding the sun itself. This inverts the temperature gradient. The energy budget doesn't balance. More energy is radiating outward than solar heating can account for. Loeb's analysis is direct and unhedged. It's very difficult to keep a surface hotter than that. If there's more energy going out than in, it means there's an energy boost coming from whipping around the sun. And that requires intelligence. This isn't the first anomaly, it's the 10th. 9 others have accumulated since 3I Atlas was first detected by the Atlas Survey Telescope in Chile on July 1, 2025. Each one, taken individually, stretches the boundaries of natural explanation. Taken together, they collapse probability to levels that make lottery jackpots look commonplace. The blue shift at perihelion is simply the crown jewel in a collection of impossibilities that suggest we're either witnessing the strangest natural object ever documented, or we're observing technology from a civilization that has mastered energy systems beyond anything in our current physics textbooks. December 19, 2025 will provide answers. On that date, 3I Atlas makes its closest approach to Earth, passing at 1.8 astronomical units, roughly 167 million miles from our planet. The Hubble Space Telescope, James Webb Space Telescope, and dozens of ground-based observatories worldwide will train their instruments on a single target, capturing data at resolutions impossible during the perihelion passage. If the object exhibits geometry inconsistent with natural fragmentation, if it emits non-random electromagnetic signals, if it maneuvers in ways that defy gravitational models, we will document the first definitive evidence of alien engineering entering our solar system. Alternatively, if natural processes can be found to explain all 10 anomalies, physics textbooks will require complete rewrites of chapters on thermodynamics, comet behavior, and interstellar object dynamics. Either outcome revolutionizes human knowledge, but the convergence point is fixed. The timeline is locked, and the blue glow remains unexplained. Perihelion arrived on October 29th. The object plunged to within 203 million kilometers of the Sun, crossing into a region where solar radiation hammers exposed surfaces with 770 watts per square meter of electromagnetic fury. This is the kind of thermal assault that destroys comets. History has documented the carnage repeatedly. Comet Ison, once heralded as the comet of the century, disintegrated completely during its 2013 perihelion passage, evaporating into a dispersing cloud of dust that never reformed. Shoemaker-Levy 9 fragmented into at least 21 distinct pieces before its collision with Jupiter, torn apart by gravitational stress alone. The pattern is consistent. Comets are fragile assemblies of ice and rock, held together by weak gravitational attraction. When subjected to intense heating and tidal forces, they crumble. The thermal stress acts like a blowtorch on frozen architecture, sublimating volatiles so rapidly that structural collapse becomes inevitable. 3. I-Atlas survived intact. No fragmentation. No catastrophic shedding of nuclear material. Instead, the object brightened dramatically, releasing energy through mechanisms that comet specialists at the Naval Research Laboratory describe in their technical reports as unclear. This structural resilience, under conditions designed to pulverize natural bodies, reinforces the foundational anomaly. Whatever this object is constructed from, it possesses mechanical integrity far exceeding dirty snowballs from the Oort cloud. During this critical passage, Earth occupied the worst possible observational position. Solar conjunction placed our planet on the opposite side of the Sun from October 21st through early November, creating a weeks-long blackout. Ground telescopes saw nothing. The moment when 3I Atlas should have exhibited its most revealing behavior occurred behind 1.4 million kilometers of incandescent plasma, hidden from humanity's primary instruments. The timing creates uncomfortable symmetry. Orbital mechanics determine perihelion dates, but the coincidence of that passage occurring precisely when Earth stands blind on the far side of the Sun introduces a pattern that intelligence planning reconnaissance would exploit. This isn't claiming intentionality. It's acknowledging that if deliberate scheduling were possible, this alignment would serve tactical advantages. 3 spacecraft maintain surveillance despite Earth's disadvantage. Stereo A orbits ahead of our planet in its annual solar circuit, positioning its coronagraph instruments with unobstructed views throughout perihelion. Coronagraphs function by creating artificial eclipses, using occulting disks to block the Sun's overwhelming brightness and reveal faint objects lurking in the glare that would otherwise remain invisible. SOHO, stationed at the L1 Lagrange point, where Earth and Sun's gravitational forces balance, monitored continuously with its LASCO imaging systems. This location provides gravitational stability, allowing the spacecraft to maintain permanent watch over the Sun's corona without fuel-intensive station-keeping maneuvers. GOES 19 represents the newest addition to this mechanical witness network. Launched in 2024, this meteorological satellite carries CCOR-1, the most advanced coronagraph ever deployed to geostationary orbit. From 35,000 kilometers above Earth's equator, it resolved details the other platforms couldn't capture. These 3 independent observers documented convergent data that eliminates instrument error as explanation. The brightness surge they recorded has no natural precedent. Luminosity extended 300,000 kilometers outward from the nucleus, creating a glowing sphere nearly the size of the Earth-Moon system. To visualize this scale, imagine standing on our planet and looking up at the Moon. Then picture that entire distance filled with radiant energy emanating from a single source. The August carbon dioxide plume detected by ground telescopes matched this dimensional scale, but the rate of brightening acceleration near perihelion exceeded anything documented from Oort cloud comets. Chi-Cheng Zhang and Carl Battams, comet specialists analyzing the coronagraph data, noted in their preprint study that 3I Atlas underwent rapid brightening ahead of perihelion, and appeared distinctly bluer than the Sun. Their analysis concluded that gas emissions contributed substantial fractions of visible brightness near closest approach, but the energy budget driving this release remains unexplained. Zhang acknowledged the comet could still be brightening, though more data collection is required to confirm whether the luminosity continues increasing or has peaked. Something extraordinary was unfolding in a region of space where only machines could observe. While humanity slept on the far side of our star, robotic instruments documented an object defying every established model of cometary behavior. It didn't fragment under thermal assault designed to destroy ice structures. It didn't dim as volatiles sublimated away. Instead, it grew brighter, releasing energy through processes that remain, in the careful language of peer-reviewed science, obscure. The blue shift in its spectral signature suggests temperatures exceeding the solar photosphere, creating an inverted thermal gradient that violates thermodynamic equilibrium. The spacecraft captured their data. The analysis teams transmitted their findings. And the conclusion emerging from Naval Research Laboratory, Harvard Astrophysics, and independent observers worldwide converges on a single uncomfortable fact. Natural explanations have been systematically eliminated. The coronagraph data from LASCO and CCOR, one converged on a measurement that shouldn't exist. Both instruments, operating independently from different orbital positions, registered 3I Atlas as bluer than the Sun itself. This isn't a subtle spectral variation open to interpretation. It's a color temperature signature that forces a binary conclusion. Either our understanding of thermal radiation is fundamentally broken, or we're observing an object with an internal power source. Every object with temperature radiates energy as electromagnetic waves. This phenomenon, called blackbody radiation, operates according to principles so reliable that astronomers use them to measure stellar temperatures across billions of light years. The relationship between temperature and color follows an iron law. As objects heat up, the peak wavelength of their emitted light shifts toward shorter, more energetic frequencies. A piece of metal heated in a forge glows dull red at first, then orange, then yellow, then white, and finally blue-white as temperatures climb toward thousands of degrees. The color directly reveals the temperature. There's no ambiguity, no room for spectral tricks or measurement errors when instruments designed to detect these precise wavelengths deliver consistent results. Blue light requires higher energy than red light, and energy correlates directly with temperature. The Sun's photosphere burns at 5,800 Kelvin, giving our star its characteristic yellow-white appearance. This serves as the baseline for comparison. At the distance 3I Atlas reached during perihelion, natural objects exposed to solar radiation should heat to approximately 290 Kelvin, roughly 20 times cooler than the Sun's surface. Objects at that temperature emit primarily in infrared wavelengths, invisible to human eyes. If they reflect visible light at all, the scattered photons skew toward red because longer wavelengths carry less energy and dominate the emission spectrum of cool bodies. 3I Atlas radiates blue light. Not reflected blue wavelengths scattered from solar illumination, but emitted blue photons generated by an object hotter than the star it's orbiting. The temperature gradient is inverted. The logical hierarchy has collapsed. It's as if you placed an ice cube next to a candle flame and watched the ice cube burn brighter and hotter than the candle. Natural comet models disintegrate under this observation. When sunlight strikes dust particles in a comet's coma and tail, scattering physics dictates the color shift. Rayleigh scattering, the same mechanism that paints Earth's sunsets red and skies blue, operates on particle size relative to wavelength. Small atmospheric molecules scatter short blue wavelengths efficiently, flooding the sky with azure during midday. At sunset, when sunlight travels through more atmosphere, blue light scatters away completely, leaving only longer red and orange wavelengths to reach our eyes. Dust particles around comets follow similar rules. They preferentially scatter light toward redder wavelengths, which is why cometary tails often appear reddish or orange in photographs. Previous observations of 3I Atlas from July through August showed exactly this expected reddish coloration. The object behaved as comets should, reflecting and scattering sunlight in ways consistent with dust and gas illuminated by our star. Then it approached perihelion and shifted blue. The color change represents more than an aesthetic curiosity. It signals a thermodynamic violation. The object's emission spectrum now indicates surface temperatures potentially exceeding the solar photosphere. Despite receiving less radiation than the sun's surface emits, Avi Loeb's analysis confronts this impossibility directly. It's very difficult to keep a surface hotter than that, he stated in recent interviews, referring to the sun's 5,800 Kelvin temperature. The statement carries weight beyond its simplicity. Maintaining temperatures above your local heat source requires continuous energy input from somewhere other than that source. A campfire doesn't spontaneously heat rocks around it to temperatures exceeding the flames. Water in a pot doesn't boil hotter than the stove element beneath it. These constraints aren't suggestions. They're thermodynamic laws enforced by the universe with the same rigidity as gravity. The energy budget refuses to balance. Solar radiation at perihelion delivers a quantifiable energy flux to 3I Atlas's surface. That incoming power can heat the object to a maximum equilibrium temperature determined by absorbed energy versus radiated energy. The blue emission spectrum indicates the object is radiating energy corresponding to temperatures far exceeding this equilibrium point. Energy out exceeds energy in. The difference must come from somewhere, and that somewhere cannot be passive absorption of sunlight. Natural objects don't carry internal fuel capable of burning hotter than stellar photospheres. Radioactive decay in asteroids generates heat, but at levels that warm interiors by hundreds of degrees at most, nowhere near the thousands required for visible blue emission. Chemical reactions between volatiles could release energy, but chemistry operates at electron-binding energies measured in electron volts. The temperatures required for blue-shifted thermal emission demand energy sources measured in thousands of electron volts per particle, approaching nuclear fusion or matter-antimatter annihilation levels. This leaves two possibilities, neither comfortable. Either our thermodynamic models, tested and validated across centuries of physics experiments and astronomical observations, are catastrophically wrong in ways that overturn fundamental energy conservation principles, or 3. Atlas employs technology. Loeb frames the choice starkly. If there's more energy going out than in, it means there's an energy boost coming from whipping around the sun, and that requires intelligence. The blue glow isn't just unusual, it's physically prohibited by known thermodynamics applied to passive objects. Every alternative explanation that preserves natural origins has been systematically eliminated through independent verification, spectral analysis, and energy budget calculations. The coronagraph data stands validated by 3 separate instruments, operated by different agencies, analyzing photons through different optical systems, all converging on the same impossible measurement. This 10th anomaly crowns a pattern that already defied probability. The blue shift at perihelion transforms 3I Atlas from a collection of curious measurements into an object that cannot exist under natural circumstances, yet demonstrably does. The evidence stream has reached a terminus, where denial requires more faith than acceptance. The blue shift represents the 10th impossibility. 9 others preceded it, each narrowing the corridor of plausible explanations until only one uncomfortable conclusion remains accessible. These aren't isolated curiosities scattered randomly across observation datasets. They form a converging pattern, each anomaly reinforcing the others, creating a web of evidence that becomes harder to dismiss with every additional data point. The first anomaly revealed itself in the trajectory. 3. Atlas arrived along an orbital path aligned within 5 degrees of the ecliptic, the flat plane where planets circle the sun. Objects ejected randomly from other star systems approach from any angle, emerging from the 3-dimensional volume of interstellar space with no preferred direction. Imagine meteorites striking a spinning plate. They hit from above, below, from any side, following trajectories determined by their origin points, scattered throughout the galaxy. The probability of an interstellar visitor aligning with our planetary plane by pure chance measures at 0.2%, roughly 1 in 500. Threading a needle in a dark room while blindfolded offers better odds. The retrograde orbit, inclined at 175 degrees, adds additional precision requirements to this alignment, suggesting either statistical miracle or navigational intent. The second anomaly violated fundamental physics that governs every comet ever observed. During July and August, ground telescopes documented 3I Atlas expelling a jet of material aimed directly toward the Sun. This anti-tail phenomenon contradicts radiation pressure mechanics. Photons carry momentum. When sunlight strikes dust particles, those photons transfer their momentum, pushing material outward like wind filling a sail. Every natural comet displays tails streaming away from stars, blown by this radiation pressure like hair streaming behind a sprinter. 3I Atlas ran forward with hair, blown into its face. The only explanations involve internal propulsion systems counteracting radiation pressure, generating thrust sufficient to overcome the outward push of solar photons and direct material sunward against the natural flow. The third anomaly emerges from mass-velocity correlations. 3I Atlas measures approximately 12 miles across and carries mass estimated at 1,000,000 times greater than Oumuamua, making it 1,000 times larger than 2I Borisov, the only other confirmed interstellar comet. Yet it moves faster than both, traveling at over 130,000 miles per hour through the solar system. Gravitational slingshots from origin star systems impart velocity inversely proportional to mass. Conservation of momentum demands that big objects move slower, accelerated less efficiently by the same gravitational interactions. Picture a fully loaded cargo ship attempting to outpace speedboats in open water. The physics prohibits it. 3I Atlas defies this correlation, suggesting active propulsion supplementing whatever velocity gravitational interactions provided during its journey from distant stellar neighborhoods. The fourth anomaly involves temporal choreography that strains coincidence. The object passed Mars at 0.19 astronomical units in early October, executed its perihelion passage while Earth stood blind on the Sun's far side, then emerged to pass Venus at 0.65 astronomical units in early November. Projections show it will swing past Jupiter at 0.36 astronomical units next March before departing the inner solar system. Meanwhile, its closest Earth approach arrives December 19th at 1.8 astronomical units, roughly 167 million miles distant. Close enough for high-resolution observation, far enough to avoid triggering threat perception or defensive responses. Imagine a tourist visiting 3 major landmarks while timing movements to avoid the main airport's security cameras entirely. The planetary flyby sequence combined with the observation blackout during perihelion creates lottery-winning odds. The fifth anomaly surfaces in spectroscopic composition analysis. Instruments detected nickel streaming from the object at rates of 4 grams per second, exhibiting nickel-to-iron ratios that match industrial alloys produced in terrestrial foundries, rather than the random elemental soup characteristic of primordial ice from stellar nurseries. Natural comets contain chaotic mixtures of elements frozen during formation in the interstellar medium, reflecting whatever materials happen to accrete in their birth clouds. Refined compositions, indicating specific elemental ratios, suggest smelting, purification, and manufacturing processes. The material signature resembles artifacts of industrial production, not natural cosmic debris. The sixth anomaly presents contradictory properties that violate comet classification. Natural comets consist of 80 to 90% water ice, earning their description as dirty snowballs. 3I Atlas contains approximately 4% water, drier than the Atacama Desert. Yet, despite this extreme dryness, it releases water vapor and hydroxyl signatures at distances approaching 3 astronomical units from the Sun, where solar heating remains too weak to sublimate ice efficiently. The Swift Observatory documented these emissions far beyond the region where natural outgassing should occur. The object functions like an iceberg made of metal that somehow still releases steam, combining properties that shouldn't coexist in natural bodies. The seventh anomaly involves light polarization measurements. When electromagnetic waves reflect from surfaces, the geometry and molecular structure of those surfaces imprint distinctive polarization fingerprints on the scattered light. These signatures act like forensic evidence, revealing material composition and surface texture. 3I Atlas returned polarization patterns absent from every natural object catalog, including 2I Borisov, the only other confirmed interstellar comet available for comparison. The reflection characteristics don't match ice, rock, organic compounds, or any combination of materials found in natural solar system objects. This suggests surface composition unknown among naturally formed bodies, potentially indicating manufactured materials or exotic substances not produced through standard cosmic chemistry. The eighth anomaly connects across decades. The object arrived from celestial coordinates matching the source region of the 1977 WOW signal, the most credible candidate for extraterrestrial radio transmission ever detected. 48 years separate these events. The directional precision resembles two arrows fired decades apart hitting the same bullseye. Radio telescopes scanning the sky register countless signals from natural sources like pulsars, quasars, and stellar flares. The WOW signal stood out for its intensity, duration, and frequency characteristics, suggesting artificial origin. Now an object exhibiting technological signatures approaches from the same cosmic address. Statistical correlation or intentional signal beacon pairing? The coincidence demands explanation. The ninth anomaly emerged from recent tracking data showing non-gravitational acceleration. NASA documentation confirms the object exhibits velocity changes not explained by gravitational interactions or outgassing thrust. Oumuamua displayed similar behavior, earning classification as a dark comet when no visible propellant plume accompanied its acceleration. Natural comets accelerate through rocket effects when sublimating volatiles create thrust, but these events produce observable gas clouds. 3. I-Atlas accelerates without corresponding plume formation. Loeb's hypothesis frames this as evidence of internal engines providing thrust-through mechanisms that don't rely on mass ejection, potentially involving electromagnetic propulsion or physics beyond current human engineering. The probability cascade collapses under accumulated weight. Multiply the individual odds. Ecliptic alignment at 0.2%. Sunward jet behavior under 1%. Mass velocity paradox in low single digits. Timing precision across planetary flybys measured in fractions of a percent. Factory-grade composition negligible in natural formation scenarios. Extreme dryness contradicting comet definition while maintaining outgassing activity creates compounding improbability. Unique polarization signatures unquantified but extreme. WOW signal coordinate match astronomically slim. Non-gravitational acceleration without visible propellant approaching statistical impossibility. Blue emission exceeding solar temperatures physically prohibited under thermodynamic equilibrium. Combined probability collapses below 1 in 10 quadrillion, worse odds than winning 15 consecutive lotteries. More likely you'll be struck by lightning twice in a single year, while holding a royal flush you didn't deal. When probability reaches these levels, Occam's razor reverses its cutting edge. The simplest explanation becomes the one conventional science has systematically avoided: technology, engineering. Intelligence commanding energy systems and materials processing beyond anything in our current capabilities. Each anomaly standing alone might permit creative natural explanations. Together, they eliminate the escape routes that preserve comfortable assumptions about our cosmic isolation. The pattern isn't subtle. It's written in spectroscopic data, trajectory calculations, energy budgets, and material compositions documented by instruments designed specifically to eliminate observer bias and instrument error. The blue glow crowns this architecture of impossibilities, adding a final thermodynamic violation that transforms accumulated anomalies into a verdict-demanding response. Avi Loeb occupies a unique position in modern astrophysics. Chair of Harvard's Astronomy Department, founding director of the Black Hole Initiative, former chair of the Board on Physics and Astronomy of the National Academies, he's accumulated credentials that make dismissing his analysis difficult. His position on 3I Atlas is stated with academic precision. Serious scientific consideration of the technological hypothesis is warranted by the data. He assigned the object a score of 4 out of 10 on the Loeb scale, a classification system ranging from 0 for definitively natural objects to 10 for clearly technological artifacts. This isn't claiming certainty. It's acknowledging that accumulated anomalies have pushed 3I Atlas into territory where conventional explanations strain credibility. Peer-reviewed papers describing the object's behavior consistently employ cautious language that reveals underlying uncertainty. Mechanisms driving the brightness surge are described as obscure. The Naval Research Laboratory's technical findings state that the brightening cause remains unclear. Carl Battams and Chi-Cheng Zhang, comet specialists analyzing coronagraph data, concluded their preprint study with the admission that the reason remains unclear. This pattern of scholarly hesitation isn't accidental. The scientific community has reached an impasse. Natural models fail to accommodate all 10 anomalies simultaneously, yet proposing technological origins remains professionally taboo. The hesitation has historical roots. Extraordinary claims require extraordinary evidence, the standard popularized by Carl Sagan that governs responsible scientific discourse. Career risk accompanies proposing alien technology as explanation for astronomical phenomena. Institutions fund research proposals built on testable natural hypotheses, not speculative scenarios involving extraterrestrial engineering. The preference for natural explanations persists, even when probability collapses, because one historical precedent haunts the discussion. Pulsars, discovered in 1967, initially appeared so regular in their radio emissions that astronomers briefly considered artificial origin before neutron star physics provided natural explanation. The lesson embedded in collective memory: wait for natural models to catch up before entertaining technological hypotheses. But 3I Atlas differs fundamentally from the pulsar case. Neutron star physics offered a natural mechanism that explained all observed pulsar properties comprehensively once the model was developed. No such fallback explanation exists for 3I Atlas that fits all 10 anomalies. NASA's Tom Statler, small bodies lead scientist, stated publicly that the object looks like a comet and does comet things, arguing evidence points overwhelmingly toward natural origin. Yet this assessment predated the blue emission data from Perihelion passage, the 10th anomaly that invalidates passive thermal models. The object simultaneously exhibits comet-like gas release while violating thermodynamic laws governing comet brightness and color temperature. Loeb's argument framework rests on principles most scientists would accept in other contexts. Scientific truth depends on data, not popularity. Evidence cannot be dismissed because implications create discomfort. He draws explicit comparison to Oumuamua, the first confirmed interstellar object, which displayed similar anomalies but provided less observational data due to its rapid departure from the solar system. 3I Atlas offers unprecedented opportunity. Its trajectory brings it close to Earth in mid-December, positioning it for high-resolution observation by instruments specifically designed to characterize distant objects. The moment of truth approaches not as philosophical abstraction but as scheduled observation windows already allocated to major telescopes. What Harvard can't explain carries specific meaning in this context. It doesn't reflect lack of intelligence among scientists analyzing the data. Physics models applied to 3I Atlas represent centuries of accumulated knowledge, tested through countless experiments and validated across astronomical observations spanning galaxies. These models are comprehensive and robust. The problem emerges not from inadequate physics, but from data that refuses to fit established categories. The object exhibits properties inconsistent with comets, asteroids, and rogue planets. Each classification scheme fails at some threshold. Blue emission at perihelion represents the final nail in conventional explanations. It requires an internal energy source hotter than the sun, a condition thermodynamically prohibited for passive objects absorbing and re-radiating solar energy. Two options remain accessible. Either thermodynamics textbooks require fundamental rewrites to accommodate processes not currently understood, or the technological origin hypothesis must be accepted as the simplest explanation fitting available evidence. Both outcomes would revolutionize human knowledge. The first option overturns physics principles validated through millions of laboratory measurements and field observations. The second confirms we're not alone and that civilizations commanding stellar-scale energy systems exist beyond Earth. Observational strategy reflects the stakes. The International Asteroid Warning Network has scheduled monitoring coverage extending from late November 2025 through January 2026. Hubble Space Telescope time has been allocated for high-resolution imaging during closest Earth approach. James Webb Space Telescope will conduct infrared analysis to detect thermal signatures invisible to optical instruments. Ground telescopes worldwide resumed observations in mid-November as the object emerged from solar glare, coordinating data collection across observatories in both hemispheres. Radio observatories maintain continuous scanning protocols, searching for electromagnetic transmissions at frequencies suggesting artificial modulation. The search parameters are specific. Instruments are configured to detect deliberate course corrections, indicating navigational control rather than gravitational drift. Analysts will examine high-resolution images for secondary objects, potential probe deployment, or structural geometry inconsistent with natural fragmentation patterns. Light curves will be scrutinized for periodic modulation, suggesting rotation of non-spherical manufactured structures. Infrared detectors will measure excess heat beyond solar heating, potential signature of active propulsion systems. Each measurement window represents opportunity to either confirm technological origin or identify natural processes capable of producing these combined anomalies. The scientific deadlock persists because resolution requires data not yet collected. December 19th marks closest Earth approach, the moment when observation geometry and instrument capabilities align to provide definitive characterization. Until then, Harvard can't explain the blue glow, and neither can anyone else using physics models built on thermodynamic equilibrium. The uncertainty is genuine, the stakes are historical, and the timeline is fixed. The blue glow is real. 3 independent instruments confirmed it through separate optical systems, eliminating calibration error or instrument artifact as explanation. If the measurement stands validated, it reveals engineering capabilities operating at energy densities beyond anything in human technological inventory. An energy source hotter than 5,800 Kelvin photosphere implies mastery over processes that dwarf terrestrial power generation. Controlled nuclear fusion, the holy grail of human energy research, operates reactor cores at tens of millions of Kelvin, but remains confined within magnetic bottles and shielding that prevent exterior surfaces from reaching stellar temperatures. Antimatter reactions release energy orders of magnitude beyond chemical combustion, but storing and controlling antimatter requires containment systems that don't themselves radiate at photospheric temperatures. The blue emission suggests either physics we haven't discovered or thermal management strategies that intentionally radiate waste heat in visible wavelengths. Scale provides perspective. Voyager spacecraft carry radioisotope thermoelectric generators, producing hundreds of watts, enough to power scientific instruments across interstellar distances. 3. I-Atlas emits luminosity, visible across 300,000 kilometers, creating a glow sphere the size of the Earth-Moon system. Converting visible light output to power requirements demands megawatts minimum, possibly gigawatts, depending on emission efficiency. This places the object's energy budget at levels comparable to small cities or industrial complexes, sustained continuously without refueling from external sources. Civilizations commanding stellar-scale energy approach Type II classification on the Kardashev scale, a framework measuring technological advancement by available power. Such capabilities don't emerge from accidental drift through interstellar space. Every documented anomaly points toward intent. The ecliptic alignment, planetary flyby timing, composition suggesting manufactured materials, non-gravitational acceleration, and blue thermal signature collectively describe an object navigating with purpose, not tumbling randomly through the void. The planetary sequence invites interpretation. Passing Mars, then Venus, executing perihelion during Earth's observation blackout, emerging to approach Earth in mid-December, then departing toward Jupiter creates a pattern resembling either gravitational assists or systematic inspection. Perihelion passage could serve dual purposes, using the Sun for an Oberth maneuver magnified to scales human spacecraft can't achieve, extracting velocity boost from close solar approach while simultaneously conducting stellar observations or material collection. The December 19th Earth approach positions the object for either final observation, targeting our civilization, or signal transmission during a window when geometric alignment favors communication. Loeb's analysis in recent Perihelion publications frames the blue color as potentially resulting from a hot engine or artificial light source, rather than passive solar heating. If propulsion systems operate through fusion, plasma acceleration, or exotic physics, thermal management becomes critical. Nuclear reactors running cores at millions of Kelvin still radiate waste heat through exterior surfaces. If those surfaces reach thousands of Kelvin, they'd glow visibly, potentially blue-shifted if thermal shielding operates at temperatures exceeding solar photospheres. The glow might represent exhaust from propulsion we can't conceptualize, energy conversion inefficiencies radiating as visible light, or deliberate signaling using thermal emission as communication medium. Natural alternatives deserve acknowledgement. The universe has surprised astronomers repeatedly with phenomena that seemed impossible before observation forced model revision. Pulsars, black holes, dark energy, each required expanding physics frameworks beyond previous boundaries. Perhaps 3I Atlas represents similar natural breakthrough, revealing comet behavior or interstellar object dynamics, not previously documented. But natural explanations must still obey thermodynamics. Energy conservation, entropy, blackbody radiation laws aren't negotiable principles subject to revision. They're foundational constraints enforced universally. No known natural process produces blue emission at 3I Atlas's distance and environmental conditions without invoking internal power generation. If natural mechanisms exist that bypass these constraints, their discovery would revolutionize physics as profoundly as confirming technological origin would revolutionize our understanding of cosmic civilization distribution. The object emerged from solar glare in November, resuming visibility from ground-based telescopes after weeks of observation blackout. It's moving through constellations Virgo and Leo, tracking outbound from perihelion along a trajectory that should trigger predictable dimming as distance from the sun increases. Natural comets follow brightness curves determined by solar heating and volatile sublimation rates. As they retreat from perihelion, energy input decreases, outgassing slows, and luminosity drops following well-established mathematical relationships. The critical question confronting astronomers isn't whether 3I Atlas will dim, but whether that dimming follows natural models or reveals powered emission sustaining brightness beyond expectations. December 19th represents closest Earth approach. The object passes at 1.8 astronomical units, approximately 167 million miles or 269 million kilometers from our planet. This distance eliminates any threat while positioning the comet within optimal range for high-resolution characterization. All major observatories have coordinated observation schedules targeting this single object during a window extending from late November through January. Hubble Space Telescope time has been allocated for optical imaging capable of resolving structural details. James Webb Space Telescope will conduct infrared analysis, detecting thermal signatures invisible to optical instruments and measuring heat distribution across the object's surface. Ground arrays worldwide maintain continuous tracking, building light curves that reveal rotation periods and brightness variations. Radio observatories scan for electromagnetic emissions at frequencies suggesting artificial modulation. This represents the most comprehensive observation campaign ever directed at a single interstellar visitor. Analysts are searching for specific signatures. Deliberate course corrections would appear as trajectory deviations not explained by gravitational models or outgassing thrust. High-resolution imaging will examine geometry, looking for defined edges, structural symmetry, or modular construction, inconsistent with natural fragmentation patterns. Signal analysis focuses on non-random emissions, whether radio transmissions, optical light modulation, or infrared patterns suggesting active systems. Thermal measurements will quantify excess infrared beyond solar heating alone, potential evidence of propulsion or power generation. Light curve analysis tracks rotation, potentially revealing non-spherical structures through periodic brightness variations. Observers will monitor for secondary objects, deployed probes or material ejecta following independent trajectories separate from the main nucleus. Two outcomes remain accessible, with no middle ground. Natural processes might explain all 10 anomalies through mechanisms not currently understood, forcing physics textbooks to rewrite chapters on comet behavior, thermodynamics, and interstellar object dynamics. This outcome would revolutionize astrophysics by revealing natural phenomena capable of mimicking technological signatures across multiple independent measurements. Alternatively, Technological signatures confirmed through December observations would provide first definitive proof of alien engineering, activating civilization contact protocols, and overturning assumptions about humanity's cosmic isolation. Either conclusion transforms human knowledge fundamentally. Probability has collapsed beyond the point where ambiguity offers comfortable refuge. This isn't archaeology, studying ancient artifacts whose creators vanished millennia ago. It's not radio astronomy, decoding distant signals transmitted across light years of space. We're observing in real time, directing the best instruments humanity has ever constructed at an object whose measured properties statistically require technology. History isn't archived footage stored in libraries. It's streaming live through coronagraphs and radio dishes, wavelength by wavelength, photon count by photon count, building toward resolution that arrives mid-December whether we're prepared or not. When 10 impossibilities converge simultaneously, the question transcends astronomy and enters philosophy. Pattern recognition is fundamental to human cognition, but it carries risk. Apophenia, the tendency to perceive meaningful connections in random data, has led countless observers astray throughout history, finding faces in clouds and messages in static. But 3i Atlas presents something categorically different. These aren't subjective patterns subject to interpretation. They're hard physics violations documented by instruments designed specifically to eliminate observer bias. Blue light at perihelion isn't open to creative reinterpretation. It's thermodynamics, measured independently by 3 separate coronagraphs, each confirming emission temperatures exceeding the solar photosphere. The institutional silence creates its own gravity. Congress is facilitating release of classified high-resolution images to scientific teams, suggesting government instruments captured data beyond publicly available observations. Scientists debate whether to publish full probability analyses, aware that combined odds below 1 in 10 quadrillion invite either ridicule or paradigm collapse. Mainstream media coverage remains predominantly silent or dismissive, treating the story as curiosity rather than potential historical inflection point. The hesitation reveals itself across multiple vectors. Career risk in proposing technological origin remains substantial, despite data accumulation. Paradigm threat looms larger than individual reputation concerns, as confirmation would overturn fundamental assumptions about cosmic isolation and civilization distribution. Yet genuine uncertainty also plays a legitimate role. The universe has surprised astronomers repeatedly, and professional caution serves science when exercised appropriately. Public figures outside astronomy ask questions. The scientific establishment navigates carefully. Kim Kardashian and Elon Musk both referenced 3i Atlas in social media posts, bringing the object to audiences who wouldn't typically follow astrophysics journals. Elon Musk discussed the anomalies with Joe Rogan, noting the non-gravitational acceleration and trajectory that brings it close to multiple planets with statistically improbable precision. This cultural penetration suggests readiness levels shifting faster than academic consensus. Cultural preparation may determine response more than scientific validation. Pentagon UAP disclosures over recent years have normalized discussions previously confined to fringe speculation. Oumuamua opened conversational space for interstellar objects exhibiting unusual properties, establishing precedent that made 3i Atlas less shocking when discovered. Each data release, each anomaly classification, each peer-reviewed paper describing unexplained mechanisms pushes the Overton window toward technological consideration as legitimate scientific hypothesis, rather than career-ending speculation. 3i Atlas forces binary decision. Accept the data and follow implications wherever they lead, or dismiss accumulated evidence to preserve comfort in assumptions about humanity's cosmic uniqueness. Loeb's position crystallizes the choice: data over popularity, evidence over consensus, scientific integrity over social acceptability. The blue glow symbolizes something beyond spectral measurement. It represents a boundary crossed, a threshold where natural categories fail and extraordinary explanations become simplest fits to available evidence. Natural objects don't carry stars within them, generating sustained emission at temperatures exceeding their heat sources. If confirmed through December observations, every assumption about cosmic isolation collapses simultaneously. The blue glow becomes a beacon impossible to unsee, forcing confrontation with questions humanity has avoided by assuming we're alone. What else have we missed by filtering observations through expectations of natural origin? How many signals dismissed as noise because accepting them as deliberate required paradigm revolution we weren't prepared to undergo? The weight of the impossible isn't carried by any single measurement. It accumulates across 10 converging anomalies until denial requires more extraordinary faith than acceptance. Right now, as this script reaches its conclusion, spacecraft instruments are repositioning for December observations. Data streams remain open, sensors stay live, and photon counts accumulate in databases parsed by teams across 6 continents. 3. Atlas is out there, moving through the constellation. Virgo at 68 kilometers per second, still glowing blue, still defying explanation. The object that shouldn't exist under natural laws continues its journey through our solar system, indifferent to whether humanity accepts or denies what the measurements reveal. December 19th will deliver not just images, but a verdict on questions humanity has pondered since consciousness emerged. Whether we've been alone in this vast cosmos, isolated on a single pale blue dot through billions of years of cosmic history, whether intelligence exists beyond Earth, distributed through the galaxy in forms we've only imagined through fiction and speculation, whether the universe contains technologies that surpass our sun's power, civilizations commanding energy systems that make our most advanced engineering look primitive by comparison, whether the cosmic silence has been broken not by faint radio whisper from distant stars but by a glowing visitor crossing through our planetary neighborhood with precision that suggests navigation rather than drift. This script doesn't provide answers because answers don't exist yet. The mystery remains live, unfolding in real time through observation windows scheduled across November and December. Every person engaging with this narrative is living through potential first contact, witnessing either the moment when humanity confirmed technological intelligence beyond Earth or documented the strangest natural phenomenon ever recorded by astronomical instruments. Either outcome transforms everything that follows. No neutral resolution exists when probability has collapsed this far and this many anomalies converge simultaneously. Nothing will be the same after December 19th. Regardless of which impossible explanation proves correct. Nothing natural should be glowing blue at perihelion. The thermodynamic laws governing blackbody radiation, tested through millions of laboratory experiments and validated across billions of astronomical observations, prohibit passive objects from emitting light hotter than their heat sources. Yet something is glowing blue, documented by multiple independent instruments operated by different agencies analyzing photons through separate optical systems. We're about to find out what technology beyond our sun looks like when it comes within reach of our best instruments, or alternatively, discover natural physics capable of producing stellar temperatures through mechanisms current models don't accommodate. History isn't archived footage stored in libraries for future generations to study with detached academic interest. It's streaming live, wavelength by wavelength, through coronagraphs and radio dishes pointed at an impossible visitor that refuses to fit comfortable categories. Hubble prepares its imaging sequences. James Webb calibrates infrared detectors. Ground observatories coordinate tracking schedules. Radio telescopes scan for signals. The observation network stands ready to document whatever December reveals. Whether 3I Atlas is the strangest comet ever born, an object challenging every assumption we've built about natural interstellar visitors, or a machine powered by physics beyond our current understanding, one fact remains inescapable: the blue glow is real. The 10 anomalies are documented in peer-reviewed preprints and technical reports. Harvard's leading astrophysicist can't explain why using models that have successfully described cometary behavior for centuries. And in approximately 6 weeks, we'll know whether the impossible requires rewriting physics textbooks or accepting that we're not alone.